Good morning. This is the math department at Amjad School for grade 11. This is the equation of the circle part 2. The objectives of this session, we will go over a revision about the previous lesson, revision about a previous skill, how to complete the square, how to find the radius and center of a circle if its equation is given, and finally, we study the position of a point with respect to a circle. First, as in the previous session, whenever you see the following icon, stop the video and try to answer the question. Please, this is very important for this video to be interactive and for you to maximize your learning experience. Also, in this chapter, the plane is referred to an orthonormal system, x or y, throughout the presentation. Let's start with the revision from the previous lesson. Complete the following. The equation of the circle C of center I 2/5 minus 3/4 and radius 3 is, that's x minus 2/5 squared plus y plus 3/4 squared equals 9. As you remember, the equation is x minus a all squared plus y minus b all squared equals r squared, where a in this example is 2/5, b is minus 3/4, and r is 3. The equation of the circle with center I minus 4, 0 and radius 3/4 is x plus 4 all squared plus y squared equals 9/16. Third example, the equation of the circle C with center I minus 3, 2 and passing through the point A is, for sure to find the equation of the circle, you need to know the center, which is given here, but you also need to know the value of the radius. Can we find the value of the radius here? For sure, since A is a point on the circle, then the distance from the center I to this point A is the radius. Consequently, we find the distance AI using the distance formula between 2 points, plugging in the value x of I minus x of a squared plus y of I minus y of a squared, square root of that, and that's 3 radical 13. So now we know the center, I minus 3, 2, and we know the radius, 3 radical 13. And consequently, the equation of the circle is x plus 3 squared plus y minus 2 all squared equals 117. Now let's do a revision about a previous skill that you have studied in the previous classes, completing the square. Examples, the expression x squared plus 6x minus 7. How can we complete the square of this expression? Since the coefficient of x squared is 1 here, we follow these steps. Take the coefficient of x, which is 6. If you look at the expression, the coefficient of x squared is 1. The coefficient of x is 6, and the constant term is minus 7. Here we look at the coefficient of x, which is 6, divided by 2, so we get 3. Square this obtained value, we will get 9. Add and subtract this obtained value to the equation, as you can see. So the expression will be x squared plus 6x minus 7 equals x squared plus 6x. So we add a 9 and we subtract a 9 and we keep the minus 7, which is originally found in the equation. So finally, this part, x squared plus 6x plus 9, is a perfect square. Consequently, it's x plus 3 all squared minus 16. Let's move to another example, minus y squared plus 2y. Complete the square of this expression. Since the coefficient of y squared is minus 1, which is not 1, first we take it as a common factor, then we follow the same steps. So taking minus common, we will be left with y squared minus 2y take the new coefficient of I, which is -2 here, divided by 2, we get -1. Square the obtained value, we get 1. Add and subtract the obtained value to the equation. So we get minus y squared plus 2y equals minus into y squared minus 2y, which is equal to minus into y squared minus 2y. We add this value and we subtract this value. As you can see, simplifying this, and this part will be the perfect square. And in this way, we have completed the square. In the previous session, we studied how to find the equation of a circle if you are given its center and radius. But now, let's do the converse. What if the equation of the circle is given? Can you find its basic elements? Yani, can you find the center and the radius? Consider this circle C. X minus 4 squared plus y minus 3 all squared equals 16. Can you find its center and the value of its radius? Matching this equation with the equation x minus a squared plus y minus b squared, clearly a and b are 4 and 3, and these are the coordinates of the center I. And the 16, which is shown in the equation, is nothing but the value of r squared. So r is radical that, and that's 4. Another example, the circle C, x plus 3 all squared plus y plus 2 all squared equals 5 has center and radius minus 3 minus 2 and radius radical 5. Let's move to a new example. The circle C, 2x squared plus 2y squared minus 9 equals 0 has center and radius. You need to find that. The coefficient of x squared and y squared here is not 1, it's 2. Then we have to divide the whole equation by 2. You have to be careful here. We're not dealing with the expression, we're dealing with an equation. So if you have a coefficient which is not preferable here, you can divide the two sides by this coefficient so that we can get rid of this 2. We get x squared plus y squared minus 9 over 2 equals to 0, or x squared plus y squared equals 9 over 2, and consequently the center and radius are clear. 0, 0, and the radius is 3 over radical 2. Let's consider the circle C, x squared minus 8x plus y squared equals 9. Can you find its center and radius? Clearly here, the circle has its equation not written in the standard form, and consequently we need to complete the square to clarify the coordinates of the center and the value of the radius. So completing the square, then we have to add and subtract 16. We get x squared minus 8x plus 16 minus 16 plus y squared equals 0. Implies x minus 4 all squared plus y squared minus 16 equals to 0. Now the circle has its equation written in the standard form. X minus a all squared plus y minus b all squared equals 16. Consequently, the center is 4, 0, and the radius is 4. Another example, the circle x squared plus y squared minus 6x plus 4y minus 5 equals to 0. I need to find the center and the radius. Again, we need to complete the squares. For x, we have to add and subtract 9. For y, we have to add and subtract 4. We get the following equation. This part will be the perfect square for x, and this part will be the perfect square for y. So the standard equation will be x minus 3 all squared plus y plus 2 squared minus 18 equals to 0. So the standard equation is x minus 3 squared plus y plus 2 all squared equals 18. And the center in this case will be 3 minus 2, and the radius will be radical 18, and that's 3 radical 2. Now let's move to the last point in this presentation. What about the position of a point with respect to a circle? A point may be inside the circle. A point may be outside the circle. And the point may be on the circle. If the point is either inside or outside, it's not on the circle. Yet we need to know if it's in the interior or in the exterior to the circle. Let me check this GeoGebra activity. As you can see, you have a circle with center I 1, 2, and the radius 3. What about the equation of the circle? Clearly here, if we apply the rule, the standard form, it's x minus 1 all squared plus y minus 2 all squared equals 9. As you can see here, A is a point whose distance from I is 5.52, and this distance is larger than the radius. So whenever the distance from the point, which we're studying, its position with respect to the circle, if the distance from this point to the center of the circle exceeds the radius, then the point will be lying in the exterior of the circle. Whereas if we consider a point whose distance, let's say, let me move this point somewhere here. Let's say, if you look at the distance here, the distance is 2.12. So the distance from the point to the center is less than the radius. And consequently, the point lies in the third case here. A lies in the interior of the circle. Whereas if I consider the distance to be exactly 3, then the point will be lying on the circle. So, if you have a circle C with center I, AB, and radius R, and A is a given point, to study the position of this point with respect to the circle, you have 3 cases. You calculate the distance from this point to the center, AR. If it's less than the radius, then A lies in the interior of the circle. If AI is exactly R, the radius, then A is a point on the circle. If the distance from A to I is more than R, then A lies in the exterior of the circle. Remark, another method to prove that a point belongs to the circle is to prove that the coordinates of this point satisfies the equation of the circle. There is no need to calculate the distance. Thank you for this presentation. A homework will be also attached with this presentation so that you can submit for the next session. Thank you.